Okay, I want us to look at grade 10 trigonometry. Trigonometry is a section that you are supposed to cover, or you are supposed to cover in your second term according to your annual teaching plan. Now, trigonometry. Trigonometry, it is very, very important to master this section, especially in this phase, because it's highly examinable in grade 11, and you are also going to be tested on these things in grade 12. But the basics and the foundation is laid in grade 10. It's a beautiful section. It's a section that is vastly applicable in the engineering field and all and many other facets of your science field. So let's look at our trigonometry. I'm going to start by basic definition of your trigonometry at this stage. Trigonometry, just take it as the study of trigonometry. This is the study of the sides and angles of a triangle, to be particular in this grade. Okay, now this is the study of the sides and the angles of a triangle. Right. Now, the first thing that I want us to do for today is just naming the sides of a right-angled triangle. What is a right-angled triangle? A right-angled triangle is a triangle with one of its interior angles being equal to 90 degrees. So, right-angled triangle. Right-angled triangle. Okay. Now, naming the sides of a right-angled triangle, a right-angled triangle. Right. Now, naming the sides of a right-angled triangle. Now, this is the key to a lot of other things that follows in this section, right? So one should be able to name the sides of a triangle. How many sides do we have on a right-angled triangle? If I would draw one, there you go. There you go. If you draw a right-angled triangle, there is my right-angled triangle. Call this triangle A, B, C. So this is triangle A, B, C. Now, with triangle A, B, C, there are three sides. Side A, B, side B, C, and side A, C. I'm trying to name these three sides. Now, the first side that you are supposed to be able to identify quickly is, remember, trigonometry was developed in grade 9 and grade 8 when we were looking at Pythagoras Theorem, and we were saying Pythagoras Theorem is supposed to be applied only on a right-angled triangle. And we were identifying one side, which we were calling the longest side, and that side was the hypotenuse. In this case, AC is the hypotenuse. So we call AC the hypotenuse. Right. How do you identify the hypotenuse? In this case, we are saying AC is the hypotenuse. How do you identify the hypotenuse? First, I said it is the longest side. So you can say it is the longest. It is the longest side. Secondly, You can also identify the hypotenuse from a right-angled triangle just by identifying that it is the side which is opposite to the 90-degree angle. The side which is opposite our 90-degree vertex. So it can also be identified as what? The side opposite the 90-degree vertex or 90-degree corner. Okay, now there you go. This is how you come up with the hypotenuse. Right, now from the hypotenuse, you've got two other sides that you still have to name, AB and BC. How do I name AB? How do I name BC? The first thing that you're supposed to get before naming those two, you can't name AB and BC without what we call the reference angle. So reference angle in this case, it is our point of reference where we are going to relate these two sides. So if I come to C and say, this is my point of reference, we call it the reference angle, and a reference angle is denoted by theta, it can be denoted by beta, so it's either you can denote it by theta, you can denote it by beta, you can denote it by alpha, you can denote it by phi. All these are used to speak of unknown, or you can also use capital letters A, B, C, D, etc. on and on. Okay, right. All these are used to denote reference angles. Okay, right. Now, so in this case, my reference angle is theta. Now, since this is theta, I'm now going to relate these two sides A, B, and side B, C. Now look at this. If you look at AB, AB, it is the side which is furthest from the reference angle. So we call it the opposite side. So AB is the opposite side. Opposite to what? To the reference angle theta. Now, if you are to come up with another reference angle and put it there as alpha, it means my opposite side changes because the reference angle is now at A, so the side opposite becomes BC. Okay, so anyway, opposite, we said you identify it by saying this is the, this is the furthest side from the reference angle. Okay, so that side which is furthest from the reference angle, we call it the opposite side. So without the reference angle, you can't get the opposite side. Once you identify the reference angle, then you can say which side is furthest from that which you call the reference angle. Okay, right. Now the next one is the side BC. If you look at BC, BC is next to the reference angle. We call it the adjacent side. So this side is called the adjacent side. We call it the adjacent side. Okay, so it means BC is the adjacent side. Adjacent is identified by saying this is the side angle. Then you'll be able to tell or to deduce your adjacent and your opposite. Okay, thank you. I'm going to give you an activity where you'll be naming and identifying these three sides of a right-angled triangle. Thank you.